Hi guys! Salamat sa inyong patuloy na pagsubaybay sa ating lecture series about surveying. Para sa iba na maaaring ito ang unang pagkakataon na makasama ko sa ganitong klase ng discussion, sana ipatuloy niyo akong subaybayan, lalong-lalo ang aking mga next uploads by subscribing to this channel. O kaya para sa inyong mga kaibigan na sa palagay ninyo ay kailangan din ang ganitong klase ng discussions, pwede nyo i-share ito para sa kanila. Okay? Guys, ang ating discussion ngayon ay may kinalaman sa bagong topic which we call as the compound curvature. Ano ba itong compound curvature? Compound curvature is defined as a curvature that is composed of two or more simple curvatures having their centers located on the same side of the common tangent. Kung meron tayong dalawa o higit pang simple curvatures that are joined together where their centers are located on the same side of their tangents, ang tawag sa kanila ay compound curvature. Kaya ganito ang itsura ng compound curvature. Halimbawa, meron tayo ditong isang back tangent, and then somewhere here, somewhere on this back tangent, ay meron tayong tangent that would intersect the back tangent, and then at that point, we can now draw a simple curvature having a radius equal to r. Diba? If this curvature is connected by another simple curvature such that the back tangent of that second curvature is the forward tangent of the first, and the forward tangent of that curvature will intersect the back tangent of the first at this point. Okay, so that from this distance, having an equal distance from this point to that point, we draw a curvature. A curvature that runs starting from this center and having a radius equal to this length, that runs in that direction. So ganito ngayon ang tinatawag nating compound curvature. It is composed of two or more simple curvatures having the centers. Ito yung centers na tinutukoy. Nasa parehong side ng tinatawag nating common tangent. So ang tawag nito ngayon ay compound curvature. This compound curvature have elements. It's very important that we should understand the different elements of this compound curvature and what are they. First, we have the point of curvature. It is the point where the back tangent intersects the first curvature at this point. Ito yung kanyang PC. Yung point na kung saan naroon ang intersection ng first curve at ng back tangent. We also have here the point of tangency. Itong point na yun naman. Ito naman yung intersection ng forward tangent and the second curve. It is the point where curve ends. We call this as the point of tangency. We also have the point of intersection. It is the point where the tangents intersect. Ito yung point of intersection nating tinutukoy. Then we also have here the point of compound curvature. It is the point where the two curves meet. Itong point na yun, kung saan yung dalawang curvature ay nag-join. Then we call this as the point of compound curvature. We also have here the length of the tangent distance of the first curve. So kung meron tayong first curvature dito, and then this distance from this point up to that point shall be called as the length of the tangent distance of the first curvature. And this distance will also be equal to this d sub 1. We also have here the length of the tangent distance of the second curve. Kung ito yung second curve natin, then this distance from here up to that point shall be our length of the tangent distance of the second curvature, normally denoted with the symbol t sub 2. And this distance will also be equal to this tangent sub 2. Then we also have here the vertex of the first curve. So ito yung ating first curvature, the intersection of the two tangents of that first curvature shall be our vertex of the first curve. Ito yun. Yung tinatawag nating intersection ng dalawang tangent ng first curvature. So kung meron tayong v sub 1, meron tayong v sub 2 representing the vertex of the second curvature. Yung intersection naman ng dalawang tangent ng second curvature is the vertex of the second curve. Ito yun. Then we also have the central angle of the first curve. Ano? Ito yung tinatawag nating intersection angle ng first curvature, which is actually also equal to the central angle of the first curve. Itong angle na ito, equal dyan, at ang tawag dyan is I sub 1. Then meron din tayong central angle of the second curvature. Asa naman siya? Actually, itong angle na ito, from this extension of this point, which is also equal to this angle. And the angle subtended by the curve, curve 2, the curvature 2, that is our central angle of the second curve, I sub 2. Then we also have the intersection angle of the compound curvature. Kung ito yung ating back tangent ng compound curvature, ito yung ating forward tangent ng compound curvature, yung intersection nila, which represent the extension of the back tangent beyond this point, and this angle will be equal to the intersection angle of the compound curvature. And you will notice by investigation that this I will be equal to the sum of I sub 1 and I sub 2, as you would note here. Then we also have here the length of the curve 1. Yung nakikita natin magbiblink dito, yan. Yung length ng ating first curvature is called as LC sub 1, or the length of the first curve. While we also have the length of the second curve, that you will see blinking here, that is the length of the second curve. The line that joins PC and PCC shall be called as the length of the first chord. That's given as L sub 1. While the line joining PCC and PT shall be called as the length of the second chord, that is L sub 2. And the line joining PC and PT is called as the length of the long chord, that joins PC and PT. We call this as L. Then we also have here the length of the common tangent, the distance from B sub 1 to B sub 2, representing the sum of T sub 1 and T sub 2, is called as the length of the common tangent. And that gives us the different elements of a compound curvature. Our concern now is to be able to understand how do we get the elements of this compound curvature. Paano ba siya kinocompute? Mas mabuti siguro na sundan natin itong next discussion natin, a problem that would show us how are we going to compute for the elements of the compound curvature. Let us have the sample problem. Given the azimuth of the following tangents, the back tangent at 225 degrees, the common tangent at 275 degrees, and the forward tangent at 320 degrees, the intersection of the back and forward tangent is at station 2 plus 100. These tangents are required to be connected by a 300 meters long compound curve. If the length of the two curves are equal, find the stationing of the PC and the length of the long chord. So, hinahanap daw dito yung stationing ng PC at yung length ng long chord given the directions of the three tangents, the back, the common, and the forward tangent, as well as the stationing of the point of intersection and the length of the two curves. So, gaya ng lagi kong binibigyan ng emphasis na kapag meron tayong problem, mas mainam at mas madali nating susundan ang ating discussion kapag na-illustrate natin at naipapakita natin yung mga elements ng ating curve base dun sa given. And then, from there, we can also determine how we are going to compute for the other elements based on the illustration. And so, let us now try to draw our illustration. We start with defining our back tangent. Our back tangent has an azimuth of 225 degrees. And how are we going to compute, to draw that direction? Now, assuming natin that here is our direction. Since azimuth is measured, recount from the south, we say from this point, from this direction south, we measure an angle of 225. So imagine that this is 225, so that we will be drawing a line directed from this point to that direction. And so this is our direction of the back tangent. And somewhere here, meron tayong point na kung saan nag-intersect ang common tangent. Let us imagine that this is the point where the common tangent is intersects, having a direction of an azimuth of 275 degrees. Again, how are we going to draw the azimuth of 275? From there, we try to draw a direction having a magnitude of 275 reckoned from this line. And so this is our direction. From this point up to that direction is our 275, and therefore the back tangent common tangent will be directed from this point towards this direction, running that direction. Imagine that we have our direction. And the forward tangent. Now, given the forward tangent, has a direction of 320. So somewhere along the direction of the common tangent, there is another tangent that runs, in the direction of an azimuth of 320. And then assuming that this is the point where it will be intersecting the common tangent, then we draw a line having an azimuth of 320. So from here, we try to draw a line that is equal to 320, and that gives us a direction of our forward tangent. And therefore, we can now establish our compound curvature. How do we draw it? Assuming natin that the intersection of the back and tangent is at station 2 plus 100. Given pala itong ating station, So where is this stationing of the forward and the back tangent? Ito yun. Itong point na ito tinatawag nating point of intersection of the two tangent, which is at station 2 plus 100. Now from there, we can also already solve for the intersection angles. Particularly, we can solve for I sub 1 and I sub 2. Because we are already given the directions of the tangents, so we can solve for I sub 1 and I sub 2. Let's start with I sub 1. Tingnan natin itong angle nito, di ba? I sub 1 actually is the difference between the direction of the common tangent minus the direction of the back tangent, and that is equal to 275 minus 225. That gives us a value equal to 50 degrees. So makapit itong angle na ito ay 50 degrees. Similarly, we can solve for I sub 2 representing this direction, and this direction is also equal to that direction. And it is equal to, by investigation, the direction of the forward tangent minus the direction of the common tangent, which is equal to 320 minus 275. That gives us a value of 45 degrees. Itong angle na yon, yung 45 degrees. Sa makatuwid, we can now compute for the length of the curvature, because in the problem, we are given that the long curve, the compound curvature has a total length of 300 meters, but the length of the two curves are equal. Hence, the first curve and the second curve would have a length of 150 meters. And from here, we can solve for the radius of the curvature R sub 1 and R sub 2. How do we get for R sub 1 and R sub 2? Given the formula that LC sub 1 is equal to 20 I sub 1 divided by D sub 1. Na kung saan ang R and D are related such that D sub 1 is equal to 1145.916 over R, or R is equal to 1145.916 over D. Kapag pinalitan natin ito ng R, sa makatuwid, this becomes equal to 20 times I sub 1 times R sub 1 divided by 1145.916. Now, substituting the value of the length and the I, so we can solve for the radius. So that 150 shall be equal to 20 times 50 times R divided by 1145.916. Therefore, R can now be solved as 171.8874. Similarly, we can solve for R sub 2 using the same formula, but substituting the value of I sub 2 of 45 degrees from this magnitude. Therefore, we can solve for R to be 190.986. And therefore, we can now plot this point. Assuming that this is our PC. Then, from this point, having this magnitude, that it will be our T sub 1. Therefore, we can compute for the position of the PCC somewhere at this point, and the position of PT somewhere at this point. So that, we can now draw a line, representing the radius of the curvature, and from there we can now establish the centers of the circle. This is the center of the first curve, such that from there we can now draw a curve that runs in this direction. And having the center of the second curve, having this radius, we can draw the curve in that direction. So this becomes now, okay, the shape of the compound curvature that represents the given. Ang tanong lamang dito ay, how are we going to get, okay, the stationing of the PC? Now let us define the elements of this curve. So we have here the PC, we have here our PCC, and we have here our PT. This radius will be equal to 171.8874 as computed by this magnitude, while this radius is equal to 190.986, that's 986, okay? So, in solving for the stationing of the PC, okay, station of PC, how are we going to solve for the stationing of the PC? Now, let us try to look at this illustration. You will notice that PC can be computed from stationing of the PI by simply substituting the distance between PC to BI representing T sub 1 and the distance from B1 to PI representing S sub 1. So that if we shall be able to compute for T1 and S sub 1, we can compute for the stationing of the PC. And so let's do it one by one. Let us now try to solve for, okay, T sub 1 and T sub 2. Okay, T sub 1 and T sub 2. How do we solve for T sub 1 and T sub 2? We have already the formula, okay, taken from the relationship between the simple curvature. That T sub 1 is equal to R sub 1 times tangent of I sub 1 over 2. We are given I sub 1. We have computed for R sub 1. Therefore, T sub 1 will be equal to 171.8874 times tangent of 50 over 2. Therefore, T sub 1 is equal to 80.15241. Then we can also compute for T sub 2 using the same formula. That is R sub 2 times tangent of I sub 2 divided by 2. Therefore, T sub 2 will be equal to, substituting the value of R sub 2, which is this one. Okay? And angle of I sub 2, which is 45. Therefore, T sub 2 will be 79.10899. And actually, that represents this distance. The distance from B sub 1 to V sub 2. Because B sub 1 to PCC is our T sub 1. And PCC to V sub 2 is our T sub 2. Now, solving now for the common tangent, okay, T will be, the common tangent T representing V sub 1 to V sub 2 will be the sum of T1 and T2, and that gives us a value of 159.2614. Now, after solving for that, we can now solve for S sub 1 and S sub 2 representing the distance from PI to V sub 2. Now, how do we do it? Now, let us try to focus our attention on the triangle formed between PI, B sub 1, and B sub 2, this triangle. Okay, let us give emphasis to the triangle by giving that color. Okay, in that triangle, okay, we know some elements of the triangle. This angle is equal to computed value of 50, while this one is equal to 45. So that with these two given angle, we can compute for this, and that is equal to 180 minus 50 minus 45, and this gives us a value of 85. So in this triangle also, okay, the value of B sub 1 to B sub 2 is already known, which is the value of T, and the magnitude was already computed a while ago. Therefore, from here, you can compute for S sub 1 and S sub 2 by using sine law, because you are given the three included angles and one of the opposite sides. Therefore, the two remaining sides can be computed using sine law. So that is by sine law, we have S sub 1 representing this one. To the sine of the opposite angle of sine 45 shall be equal to S sub 2, this one. Okay, divided by sine of 50 degrees shall be equal to the value of T, which is already known, okay, over sine of 85, the opposite angle. When we substitute the value of T at 159.2614 to the equation, then we can solve for S sub 1 at 113.045 and S sub 2 at 122.4673. Now, what shall we do after solving for S sub 1 and S sub 2? So, after solving for S sub 1, we can compute now for the stationing of the PC, because PC can now be solved from this magnitude minus S sub 1 and T sub 1. And that is equal to stationing of PI minus S sub 1 minus T sub 1. That if the value shall be substituted, okay, S sub 1 is 113.045 and T sub 1 was just computed a while ago at 80.15241. Therefore, stationing of the PC is at 1 plus 906.803. So we already have computed for the first question. What about the second question, the length of the long chord? Where is the length of the long chord? The long chord is the line that joins PC and the PT. It's 1. So that is the length, which is actually what we are looking for. Now, to solve for this, let us try to consider the larger triangle formed between PI, PC, and PT. Okay? PI, PC, and PT. Do you see the triangle? Okay? So, in the triangle, you will notice that the two sides are already known. Okay? The PI, PC, the distance from PI to PC, which is the sum of T1 and S sub 1. And that is equal to 80.15241 plus 113.045, and that gives us a value of 193.1974. While the value of the distance between PI to PT is actually the sum of S sub 2 and T sub 2, that is T sub 2 plus S sub 2. Now, if the values are substituted, we have 79.10899 for T sub 2, while 122.4673 for S sub 2. Therefore, the distance between PI to PT is equal to 201.5763. And now, looking further at this triangle, you will notice that this triangle now consists of two sides known, okay, this distance and that distance, and the included angle at 485 degrees. Therefore, the third side representing, okay, the length of the long chord can be computed using, okay, the cosine law. Therefore, solving for the long chord using the cosine law, how do we solve for the cosine law? That is the square root of, okay, the square of, okay, this distance representing 193.1974 squared plus the square of S sub 2 and P sub 2 representing 201.5763 squared minus twice the product of 193.1974 times 201.5763 cosine of 85, and that the value of L is equal to 266.7768. Guys, I hope that you're able to follow the computation that I have presented in our example. And with that example, able to understand, okay, what a compound curvature is and how do we compute for the elements of the compound curvature given other elements. I hope that you will continue following my discussion by subscribing to this channel and share also my channel. Again, I'd like to say thank you for watching.